Hello guys, today we will be implementing Perceptron or a single neural network in Tensorflow. So first, take a closer look at what is a Perceptron. So Perceptron is a basic computation unit. So what it does, it takes an input or an input vector and then produces an output, which is a scalar. So to do so, it has a set of weights and a bias and an activation function. So what it does, given a set of input like this, we will have a weight vector like this. Then we will compute the pairwise product of x1, w1, x2, w2, x3, w3 and so on, and sum them up and add the bias term with it. And then we will pass our output to our activation function. So activation function is nothing, it's just a function that we can easily define. Like for this case we have a simple thresholding. So if this is greater than equals to 0, then we will output 1, and if this is less than 0, then we will output 0. So this is the most simple activation function. Here we can have more activation functions like sigmoid, relu and all that. Now let's take a closer look at how we can actually train, or what is the magic about Perceptron. So basically, after all this step, we are basically producing an output from a set of input. We call this y bar. And while training, we also know the original output, that it is suppose the original state, and we are predicting something y hat, and suppose our original will be y. So then from our predicted and original, we always wanted to predict the original one or predict it correctly. So basically we will try to quantify the difference between y and y bar, or the loss between y and y bar. So we have a lot of loss functions. So some of them are, for regression we use a squared loss, which is the Euclidean distance between the predicted and the original output, which is nothing but y minus y bar square. And for classification we have a cross entropy loss, so which is also probabilistic interpretation of this difference between y and y bar. So basically our main goal is to reduce this difference, or directly reducing the loss. So how we actually can minimize the loss? So let's discuss on that. Now what we are trying to do is, we are trying to teach this Perceptron the mapping between the input and the output. So initially we will initialize this weight and bias randomly. We will initialize all these weights and the bias term random. Then we will compute our output, and we will measure the difference between the original and the predicted output, and then we will adjust our weights accordingly, and then we will do the same step until the predicted output is same as the original output. This is our whole training process. So you can see this is visualizing the whole training process. So after each iterations, it tries to classify all the points correctly. So we can say after 12 iteration, it almost classifies all the points correctly. So we have a lot of mechanisms to do this. The most simple of them, or the most famous of them, is the gradient descent. So what is basically a gradient descent? So first we initialize the weight randomly, and we compute the loss, and suppose this is a loss function somewhere. Then what we want to do is, we want to minimize this loss function. So this is our most minimal form, or this is the minima that we want to reach. And with our initial weights we have this we are here in the scale, in the graph, in the space of loss. So we want to reach this minima. So to do so, what we need to do is we need to descend along the gradient of this function. So in later videos we will take closer look into gradient descent. For now on, this is basically the whole process. So here is another visualization which says in the error surface, this is the error surface, and this is where we started with our initial random weights, and this is the point what we want to reach, the point of minimum or the point of optimality.